Good morning. It is Friday, and as I told you guys, today we're going through the statistics review, and your test is on Tuesday of next week. Okay, so don't forget that. Tomorrow we're going to come, not tomorrow, Monday, I'm going to come back and make sure if you have any questions about this that you can ask and have time to still study it. The test will be on Tuesday. Everything's still on track as far as our plan that's up on the board. And hopefully, after yesterday, there'll be no more crazy interruptions as far as class time goes. Because testing, I think, should be over for the most part when it comes to everybody schedule changing. So, all right, we're going to go ahead and jump in here. And you should have your review. If you don't, Miss Bowles probably has a couple of extra ones that she could distribute. But let's go ahead and kind of talk through this. So number one, determine if the following is an observational study or experiment. So just right off the bat, let me remind you, if it's observational study, you're not causing something. You're not actually, doing anything except kind of stepping back and looking to see if something is happening. But if it's an experiment, you're causing it. Okay, you're controlling something, and then you're watching that to see if it causes changes. So here's what we got. You want to know if reading to children every night before bed affects the age they begin reading on their own. You choose families who read to their children every night before bed, and you choose some families who do not. You record the age children in each group begin reading on their own, and you compare. All right, so clearly this one is an observational study. Now, if you just think about it from a logical standpoint, are you causing something here? Like, are you going into these houses and reading to these kids at night and seeing, how long it takes them to start reading on their own? Of course not. Okay, it's an observational study is because you can't control anything. All you can do is you can talk to families who either read each night or talk to families who don't read each night, and then see what happens as you look at the age that children start reading. I hope that makes sense because, again, observational study, you can't cause something, you can't control something, you're just stepping back and looking. But with an experiment, you can, okay? You're in control. All right, now, a part of the test is obviously this standard deviation and mean and how it relates to a normal curve. We talked about all these values. We talked about how your mean goes right in the middle. So if you read this, it says the number of days a group of 250 homes is on the market is normally distributed with a mean of 50. Because let's start with that mean of 50. That 50 has to go smack dab in the middle. That's where your mean goes. And then it says that you have a standard deviation of 13. Also very, very important, okay? The standard deviation is what controls what happens to this number as we move to the right and to the left at all of these different standard deviations. So to the right, we're going to add 13. To the left, we're going to subtract 13. So let's go do that. 50 plus 13 is 63. 63 plus 13 is 76. And 76 plus 13 is 89. Go in the opposite direction. 50 minus 13 is 37. 37 minus 13 is 24. And 24 minus 13 is 11. So there you have it, okay? Now, the second thing that's also very important that you guys need to be able to do is remember the numbers that are inside of here when it comes to percentages. Remember, one standard deviation is 68% of your population. So divide that by 2, that's 34% in both of these two areas. We said that 2 standard deviations, which includes the 24 all the way to 76, that's 95%. So if we do 95 minus 68 and divide that by 2, these are both 13.5. It's one of the very few things that you actually have to memorize going into the test on Tuesday. And then 3 standard deviations is 99.7. Well, if you take 99.7 and subtract the 95, that's 4.7 divided by 2. That's 2.35 in both of these two slots. Now, the last thing, there's 0.3 that gets divvied out into these two little locations here. So 0.3 divided by 2 is 0.15. 0.15. So here's the deal. If I tally all of these percentages up, that's 100% of this total population of 250 homes. Okay? So now we're going to answer questions based on that knowledge. If you've done all this right, it's really impossible to miss these. They're going to ask you 2 types of questions. See, 2 and 3 are the same. Okay? 2 says, and here's what I mean by the same. Number 2 says, what percent of homes? Where number 3 says, what is the probability that a home? Those are both asking you a percentage. But number 4 says, approximately how many homes? That's asking you for an actual number. So as long as you have all this filled out correctly, and you understand what the question's asking you, this is really quite simple. So let's start with number 2. Now, fortunately, I can highlight. You can't. I guess you can, but you'd have to erase and it would be a mess. But it says, what percent of homes are on the market between 11 and 89 days? Now, look, 11 starts here, and it goes all the way over here. Now, there's 2 ways of doing this. You could either add up all of these highlighted regions, or you could remember that that's 3 standard deviations in both directions. Well, we already know that number. 3 standard deviations is 99.7%. Now, feel free to go 2.35 plus 13.5 plus 34 plus 34 plus 13.5 plus 2.35. In fact, if you can't remember that 3 standard deviations is 99.7%, but you can remember all these numbers, then by all means, please remember to add those up. All right, let's move to number 3, which asks the same question. What is the probability? That's just like saying, what's the percent? Okay? So what does it say? What is the probability that a home is on the market for at least 37 days? Now go find 37. At least means that is the least. That is the smallest amount. So this being the smallest amount means it includes everything that's above that. Now again, you're welcome to go add up all of these. 34 plus 34 plus 13.5 plus 2.35 plus 0.15. What I did was, I know that this line right here divides this into 2. This is 50%, so I go 50% plus 34%. 50% plus 34% is 84%. But again, if you add all these up, 34 plus 34 plus 13.5 plus 2.35 plus 0.15, it will also give you the 84%. Promise. Now, the last one, again, like I said, it asks a little different question. It says approximately how many homes. So this time, we're not actually finding the percent. Well, I'm sorry, we are actually finding the percent. But we're answering it by saying exactly how many homes. So let me explain. First of all, how many homes were on the market between 37 and 63 days? So 37 is here, and 63 is here. That's 1 standard deviation. 34 plus 34 is 68%. Well, if I go put 68% over here, wrong. Okay, it's wrong. So please pay attention. It's that 68% of all homes. Well, how many homes are there? There's a total of 250. So 68% of 250 homes. Now again, I can't go 68 times 250. That would end up being way more than 250. It's 68% of 250. That means I do 0.68, that's 68%, of times 250. So 68% times 250 is 170. That's 170 homes. Okay? 170 homes is our answer. Okay, I'm going to erase this highlight. And here's the deal. Number 5, it says the wind speeds throughout the month of April were normally distributed with a mean of 17. Okay, we just talked about this. A mean of 17 and a standard deviation of 4. They want to know what percent have winds between 5 and 13. So you could try to do this in your head, but here's what I'm going to do. I'm going to go up here, and I'm going to take this very one that we just talked about, and I'm just going to replace some numbers. I'm going to put 17 as my mean, and I'm going to do a standard deviation of 4. So plus 4, 21, plus 4, 25, plus 4, 29, 17 minus 4, 13, minus 4, 9, minus 4, 5. So if I look at this now that I've discussed or changed those bottom numbers, instead of redrawing this thing and starting fresh, I'm just going to look at this and it says between 5 and 13. Well, here's 5, y'all, and here's 13. That is 13.5 plus 2.35. Now, it says what percent. So this one is more like number 2 and number 3. All we have to do is add up those percents. So 13.5 plus 2.35 gives me an accumulated percent of 15.85%. Now, I don't want you rounding. If it's a decimal like that, I want you to leave the decimal and move on. That is your answer. Okay? So on the test, if you come across one where you are able to use the same drawing that you've done above, but just with different means and different standard deviations, then just write that underneath and just go through the same process. All right, let's flip it over to the back of that one. Here we have a table, 1, 2, 3, 4, 5. We have 4, 6.8, 8.19, 9.5, and they want me to use a scatter plot to determine if a linear, quadratic, exponential, or logarithmic equation would fit best. Then find the equation that goes with it, and then use that to predict the height of a tree at 15 years old. All right, so let's go to our calculator. Now, I'm going to reset it. You've probably already done this, but if you haven't, let's reset it. We're going to go enter some data. So remember, to enter data, I'm going to go to Stat, Edit. And here we go. I got 1, enter. 2, enter. 3, enter. 4, enter. 5, enter. Let's go to the other side, and they have to match up, right? So we got 4, enter. 6.8, enter. 8.1, enter. 9, enter. And 9.5, whoops, 9.5, enter. All right, so we have to decide, does this data right here represent a line, a quadratic, an exponent, or a logarithm? So I need to go look at the graph. So I go right here to second, y equals, and I turn this stat plot from off to on. Okay? From off to on. Then I go to zoom, and I want to zoom in on my stat data, number 9. So there you have it. Now let me go back to my paper real quick, because I want to remind you guys, here were your basics, okay? If it's dead straight, or it doesn't look like it's really turning or got any type of curvature whatsoever, if it looks like it's pretty straight, it's going to be a line, so we'll run a linear regression. If it looks like this, obviously it is what we would call a quadratic, so we would run a quad reg. Now, you know that both of these could go down from left to right, or this one could be flipped upside down. Exponential also has 2 looks. One, it starts flat and then it gets steep. Or it drops fast and then it flattens out. this would be an exp reg. Okay, one of them is exponential growth, and one of them is exponential decay. The other one, the final one, is a logarithm. And a logarithm does kind of the opposite of exponential. It starts by going steep, but then it kind of flattens out. And you run an ln reg. We just talked about this recently, so that should be pretty current in your brain. Let's go back real quick. Which one does that look like to you guys? You see, it doesn't look like it's straight, because if I go from the first point to the last point, all of those points are kind of above. So instead, it looks like it's going up a little steeper and then flattening out. So I'm going to go with a logarithm. To me, it looks like it's a perfect logarithm. I'll say this, on the test Tuesday, if you are familiar with these graphs, it will be 100% clear which one it is. Okay, I can promise you this. So let's go back and let's run a regression. So we're going to go to stat, scroll over here to calculate, and there's our linear, there's our quad, there's our logarithm, and then of course there is one more, and it's right here, exponential. So we're going to run a logarithmic ln reg. So I push enter a few times, and then it writes my equation for me. So it is going to be y equals, we're going to go to 2 decimals, so that 9 rounds that up to an 8. So we're going to go with 4.18a plus b, we're going to go with 3.45 ln of x. See, look, it gives you the formula and everything. You just got to plug these values directly into it. Now, I like to go back to y equals and plot this. So I'm going to go 4.18 plus 3.45 ln of x. I'm going to graph both together, and sure enough, that looks like a pretty good logarithm. It's hitting every point, actually. So I can feel pretty confident about any prediction that we're going to make. Well, what does it want me to make? Predict the height of a tree at 15 years old. So I'm going to go to my calculator, and I'm going to type in 4.18 plus 3.45 ln of 15. So let's do that. Go back out to your home screen. You can just start typing 4.18, goes back out to the home screen for you, plus 3.45 ln of 15. And the predicted height is going to be 13.52 feet, I assume. Let's go back and look. Yeah, it says in feet. So 13, see, height in feet, 13.52. And that's it. That's how you do it. Okay? Very simple. All right, let's read number 9. The top 100 male weightlifters were tested on the bench press. They averaged 515 pounds for 1 repetition. The margin of error. Okay, we talked about that. It's been a minute. The margin of error is found to be 10 pounds. So between what two values can you expect the population mean to fall? Well, we talked about this. With margin of error, we are going to add and subtract this value, this margin of error. So I'm going to do 515 minus 10. That's 505. And I'm going to do 515 plus 10. That's 525. That margin of error gives me an opportunity to say, hey, listen, if they average about 515 for 1 repetition and the margin of error is 10 pounds, we can be really confident that that true population mean falls somewhere between 505 and 525. Okay? Very, very simple problem. Please don't miss that one. Okay, number 10. It says a sample of 11th grade students were asked their favorite academic subject. So you got math, which I feel like is a little low. You've got English, science, social studies, foreign language. What is the estimate population proportion of the least preferred subject? And it says give the answer as a decimal rounded to 2 decimal places. So hopefully you guys remember when we talked about population proportion, I told you you're going to set up a fraction And that fraction is going to include the top number, which is the specific thing they're talking about. Well, what is the least preferred? The least preferred is science at 16. That's going to be your value up top. So what's the bottom number? Well, the bottom number is everything. So we're going to actually tally these all up. That's 20 plus 30 plus 16 plus 45 plus 34. So my total that goes in the bottom is 145. Now what does it say? It says what is the answer as a decimal rounded to 2 decimal places. So we're actually going to go in here and we're going to type this in. Now don't go up here to alpha y equals, because a lot of times when you do that, and it might not work out here this time, a lot of times when you do this, it just simplifies the fraction. Well, we don't want to simplify the fraction. We want a decimal. So you have 2 options. You could either do this, and then you could do alpha y equals and turn a fraction into a decimal, number 4. Whoops, I didn't mean to do that. Alpha y equals number 4. And that is 0.11. The other thing is, instead of doing a fraction at all, you could treat this division as division and go 16 divided by 145. That's the way most people like to do it. But you see, it's the same answer. So our answer as a decimal is 0.11. Okay? So that takes us through page 1 and 2. Let's flip over to the back and let's talk about page 3. Now page 3 is going to be quite a bit of calculator work, and then it's going to have a couple of other things. So first things first, let's talk about how we can use our calculator with all of this data to find our mean, our median, our standard deviation, and our variance. Now the one thing it won't find for me is it won't find my mode. I have to do that on my own, and we'll do that in just a minute. But let's go use our calculator to find all these values. First, let's reset it. Second plus 7, 1, 2. We're going to go to stat edit. That's where we go when we want to enter data. And I'm going to enter all these numbers. Okay, here we go. 89. I'm not going to talk. I'm just going to enter them. Double check every once in a while to make sure you're not going so fast that you're typing something in wrong, because that'll kill your data more than anything else in the world. Because you're going to get an answer and you won't even know if it was right or not, because you will have entered all these things blindly. I like to double check them too, just because, I mean, hey, this is a test. I don't want to miss one because I got lazy or fast. 60, 100, 84, 93, 95, 78, 67, 90, 82, 77, 81, 86, and 65. Perfect. I got them all in there. All right, we're going to go to one place to find all 4 of those that I just highlighted. We're going to go back to stat. We're going to go over to calculate, but we're not running a regression. We don't want an equation. We want all these stats. So we're going to do number 1 var stats. Okay, now just make sure we understand this. X bar, that is your mean. So my mean is 81.6. Okay? Now what about median? All right, well, it's none of these. We're going to scroll on down, and there it is. MED, that is your median. So my median is 82. Now, standard deviation is this one right here. A little circle with a hat. Okay, I don't know how you want to remember that. That's standard deviation. So rounding to two decimals, we're going to go with 10.98. Now, variance, I said all of them. See, I highlighted this. I kind of lied. I said they're all here. Well, they're not really. Variance is not here. But we take the 10.98 and we square it. And that is my variance. So even though it's technically not there, it's there. If that makes any sense. So here's all the numbers that the calculator gives me when I run that problem. So, my mode. That's the only thing that's not. Remember, mode is the most often occurring. So, here's how we do this. Look at all your numbers. Is there another 89? No. Is there another 77? Yeah, there's a 77 here. There's a 77 there. You see any more? No. Is there another 60? No. Is there another 100? No. Is there another 84? No. 93? No. 95? No. 78? 67? No. 90? No. 82? No. 81? No. 86 and 65. So the only repeated value is the number 77. That is my mode. Now remember, if there are two modes, that means they're both repeated the same amount of times. Okay? It's whatever gets repeated the absolute most. That is your mode. So there you have it. Okay, that's how you find your mean, median, and mode. Now I ask one more time to label the normal curve with all the values. Here's what I mean by that. See, we just found this, and we know then that 81.6 goes right in the middle. And then my standard deviation is 10.98. All right, 10.98. Now let's just round that up, and let's use the standard deviation of 11. So 81.6 plus 11 is 92.6. 92.6 plus 11 is 103.6. 103.6 plus 11 is 114.6. Go in the opposite direction, we got 70.6. Going another, we got 59.6. And one more, 48.6. So there's all my mean and my standard deviation. I just rounded that standard deviation to a decent number. We didn't want to add and subtract 10.98. Same for the test tomorrow. And the one thing else I want you to label are these values. You got 34, 34. You got 13.5, you got 13.5. You got 2.35, you got 2.35. You got 0.15, and you got 0.15. Don't forget to memorize those numbers, okay? So that's number 16. We've labeled the normal curve with all the values, the mean, the standard deviations, and the percentages that are underneath. Okay, number 17. A GC quad determines the club head speeds for all the golfers on CCHS golf team. If the mean is 100 and the standard deviation is 3.6, find the z-scores for each of the players. So let me remind you guys of z-scores. Remember, the formula for z-scores is you take the x, you subtract the mean, and you divide by the standard deviation. So we have to basically look at what we've been given and plug in all these values. So what did the question give me? It gave me the mean. The mean is 100. Guys, that's right here. That's where 100 is going to go. And it gave me the standard deviation. That goes here. So when I talk about Brady's speed, Maggie's speed, and Costello's speed, that has to be the value that goes where then? Well, X. Because we're finding the z-score. We're finding this value that's over here all alone. So for all of these problems, we're simply going to plug it in to X. So for this one, you're going to go 94 minus 100 divided by the standard deviation 3.6. Okay? Now, I would recommend either use alpha y equals number 1 and do all of it up top, 94 minus 100 divided by 3.6, and see if it gives you a decimal. And it does. And it told me to round Actually, it didn't tell me to round. So we're going to go to 1 decimal. So that's going to be negative 1.67. Okay, so there's the first one. Second one, Maggie's. We're going to plug 98 in here. Minus the mean, 100, divided by the standard deviation, 3.6. So I go back to my calculator. Alpha, y equals number 1, 98 minus 100 divided by 3.6. Enter. So here we get negative 0.56. And then finally, 108 minus 100 divided by 3.6. So let's go back to our calculator. Oh wait, actually didn't leave it. So we're going to do 108 minus 100 divided by 3.6. So that's going to be 2.22. Now let me go back to my paper. I meant to. I'm sorry about that. So there you have it, okay? Now, that is the second thing you need to remember how to do. Second formula, I don't know. I haven't decided. Maybe I'll give that to you. We'll talk about it on Monday. But anyways, let's move on to number 18. 18, same thing. It's same formula anyways, and here's how I know that. I see the word z-score. But this time they give me my z-score, okay? So if you go back up to that formula we talked about just a second ago, right there, where is that z-score? What's out front? So we're going to put negative 2.2 out front. What else did they tell me? Well, they told me that the CCHS pitchers was 87. Well, what about it? Well, the mean number of total pitches was 87. Where does that go? Well, mean is right here. That's where 87 goes. All right? Let's see what else they tell me. And there's a standard deviation of 3.2. Well, where does that go? Well, standard deviation's right here. So we're putting the 3.2 right there. So if Bo's z-score was negative 2.2, find out how many pitches. Find out x. We don't know how many pitches he actually threw. So that's what we're trying to find. All right, so here's my process. How do I get rid of this divided by 3.2? You got to multiply by 3.2. So I'm going to go up here. I'm going to go negative 2.2 times 3.2. And that gives me negative 7.04. Okay? So let's go back to my paper. Negative 7.04 equals x minus 87. So how do I solve this from here? Well, add 87. So negative 7.04, which we just got, plus 87 gives us a score of 79.96. Now, let's go back to my paper because, listen, let's think logically. How many pitches did he throw? Did he throw 79.96 pitches? Of course not. Okay, we're going to definitely, because of the value, we're going to round that up to 80 pitches. You can't throw 79.96 pitches, okay? But you can throw 80 pitches, and that's what 79.96 rounds up to, okay? Number 19. A set of test papers is normally distributed with a standard deviation of 5. Okay, my standard deviation is 5. Then it says that Jared scored a Jared scored a 92, and the z-score he got was positive 2.2. So let's go back up here real quick. And let me erase this highlighting on this formula. I didn't mean to erase all that. I guess it doesn't like me leaving it there. All right, so let's look at this. They told me standard deviation right here, 5. So I'm going to put 5 in the bottom. They told me that Jared scored a 92. Well, his score is right here, 92. All right? They told me that his z-score, that's here, is 2.2. So clearly, we're missing this value right here, which we know is the mean. All right, so there it is. This is our formula with all the values they've given me plugged in, and of course that missing mean value. So first things first, we still need to multiply by 5 to get rid of that. So 2.2 times 5 is a total of 11. So 11 equals 92 minus the mean. Now you got a couple ways to do this. I always add the mean. So you got 11 plus the mean equals 92. And then that allows me to get the mean alone by subtracting 11. So my mean is 92 minus 11, which is 81. So the mean is 81. Okay? And then the last one, the heights of a group of trees is normally distributed with a mean, so this time they're giving me mean, 14.6. A z-score was 1.4. And then they told me one other piece of information. I don't know if you caught it. They told me that the z-score for an 18-foot tree, that is the x. We're missing the standard deviation, okay? So here's my equation. The z-score goes out front, 1.4, and that equals my actual value, x, 18, minus the mean, 14.6, divided by the standard deviation. Obviously, just like I have with these other problems, we're going to multiply by that fraction. So we're going to multiply by our standard deviation. And then, of course, I'm going to go type in 18 minus 14.6. 18 minus 14.6 is 3.4. So finally, to get our standard deviation alone, we're going to divide by 1.4. And our answer is 2.43. My standard deviation is 2.43. And that's it. Okay? That's really quite simple if you know how to use this formula. Okay? We'll discuss whether I give you guys that on your test. But there it is. Okay? That is your review. Now this video is about 38 minutes, so you have a little bit of time left. But I do want to remind you guys that tomorrow or Monday, I'll answer any questions that maybe you still have about these review questions. And then we will study for the rest of that time and be prepared to take that test on Tuesday. All right? I hope you guys have a great weekend. I appreciate you guys' attention, and we'll see you on Monday.